Let's take a look at this problem. I pick 7 apples per minute. There are some apples in my bin to begin with. I pick apples for 12 minutes, and at the end, there are 150 apples in my bin. How many apples were in my bin to begin with? Well, let's imagine what this situation is like. I've got a bin. It's filled with some apples. There's some apples already in there. And I start to pick 7 apples per minute. I'm putting those into the bin. I do that for 12 minutes, and altogether I've got 150. So my rate is 7 apples per minute. I do that for 12 minutes. And in the end, I get a total of 150. So 7 times 12 plus the apples that were in the bin to begin with equals a total of 150. Seven times 12 is 84. And then I've got this extra amount, and those together equal 150. If I were to imagine that, picture it as a bar, the entire bar would be worth 150. I would have 84 be part of it. B would be the other part, and together they make 150. Well, that makes it clear to me that I need to do 150 minus 84 to find out what B is. 150 minus 84, 150 minus 4. Let's do it this way. 150 minus 80 is 70, and then 70 minus 4 is 66. So 66, that's what B is. Those are the number of apples that I had in my bin to begin with. This situation is a situation that we're going to run into a lot. And I'd like to talk about how to solve this equation as an algebraic equation. Now, this may seem simple, but some rules that we'll learn will help us to solve some problems that aren't always obvious. The answer is not quite as obvious as you might think. When we saw this as a bar model, we saw that 84 plus the B together made 150, and we needed to take 84 away from 150 to figure out what B was. And if you look at the equation, you can see that the same thing is true here. We've got 84 and B together to make 150. If I take 84 away, I'm left with just B. If I actually, right over here, take 84 away from 150, I see that that's going to give me the answer. And this may look a little bit strange, but an algebraic equation has 2 amounts. There's this amount and there's this amount, and they're equal to each other. So when you take something away from one of the amounts, in order for it to still be equal, you have to take the same amount from that other amount. So 84 plus B, 84 and B together, if I take the 84 away, what's left? B. And 150 minus 84, that gives me 66. Here are some other examples. Let's do 12 plus M is equal to 103. If I take 12 away from 12 plus M, I'll have just M left. And if I take 12 away from 103, I get 91, and that tells me that that's what M is. Now, I want to make sure that 91 actually is the right answer. Maybe I made a mistake in my arithmetic. I'm going to evaluate the equation that I've got at the beginning. I'm going to take that m out and put the value that I think m has in its place. Does 12 plus 91 actually equal 103? Yes, it does. That'll help if you do that check procedure. That'll help you catch a lot of errors that sometimes crop up when you're doing algebraic equations, you're solving equations. All right, let's take a look at another situation. How about x plus 17, and that equals 300. X and 17 together are 300. So if I take 17 away, I'll be left with just x. And if I take 17 away from the 300, that'll tell me the value that that equals. X equals 283. Let's do our check. I'm going to evaluate that equation for x is equal to 283. I'll replace the x with 283. That plus 17, does it give me 300? Yes, it does. Now let's take a look at some problems that are a little bit more complicated or a little bit less obvious. Let's say n plus 9 equals 2. Well, if you step back and think about it, something plus 9 is going to give me 2. It's clear that that's got to be a negative number. In fact, you may be able to see that that n has to be negative 7. But let's see how the procedure that we've been using will lead us to that negative 7 automatically. N and 9 together make this amount. I want to take 9 away to leave just n. If I do it on the other side, take 9 away from this amount, 2 minus 9 equals negative 7. And again with the check, yep, I did my arithmetic correctly. How about 11 plus m is equal to negative 15? All right, well 11 and m together make negative 15, so let's take that 11 away. And 11 plus m with the 11 taken away leaves just m. And if I take 11 away from the negative 15, negative 15 minus 11 is equal to negative 26. Now looking back at the original equation, I'm not sure that I would have guessed that. Maybe you would have. But this procedure leads us to it automatically. Well, let's check so we did it right. Let's take a look at one more example. Well, what I've been doing so far is x and this amount, I take that amount away. So that means that I'm going to do minus negative 13. And we know that that's the same as adding 13. X plus negative 13, if I take negative 13 away, that's going to leave just x. If you think about this as adding 13, negative 13 plus 13 leaves 0. So either way you look at it, you have just x, or x plus 0. Over on the other side, I'm going to take away negative 13. That's a double sign. We like to think of things in terms of just a single sign, so that's the same as negative 28 plus 13. Negative 28 plus 13 gives me negative 15. Now, I don't know about you, but I'm certain that I couldn't have figured out just what that number is just by looking at it. Now that I look back at it, maybe I could have. But it still is an automatic procedure that always leads us to the answer, and that's a nice thing to have. Let's, in the last step, do our check. Yep. So we know our arithmetic's right, as well as our procedure. I think you'll find this to be useful, and we'll expand on these ideas in later lessons.